I'm going to show you how to tackle an examination paper. This is paper 1 for March 2020. This paper is for both AS and A-level mathematics. This paper also is the first one to be based on the new syllabus. So you will have newly added chapters such as transformation of curves and equation of circles. Also, you won't have question on vectors because vectors has been omitted from the paper 1, but we have vectors in paper 3 only. As for the duration of the paper, it is now 1 hour and 50 minutes. Previously, it used to be 1 hour and 45 minutes. So here you have the instructions which you have to read properly. And the paper is on 75 marks. Let's see the first question. The function f is defined by fx is equal to 1 over 3x plus 2 plus x squared for x is less than minus 1. Determine whether f is an increasing function, a decreasing function, or neither. So this chapter is differentiation. And here we are talking about increasing or decreasing function. So we have fx is equal to 1 over 3x plus 2 plus x squared. And the function is defined for the domain x is less than minus 1. This is the domain of the function f. Now, to determine whether it is increasing or decreasing, we have to calculate an expression for f dash of x. That is the derivative of fx, which is also known as a gradient function. So, when we differentiate, we obtain, so first of all, we write fx as 3x plus 2 power minus 1 plus x squared. Then we differentiate. When we differentiate, we obtain minus 3x plus 2 power minus 2 times 3. We differentiate the expression inside the bracket, and then we differentiate x squared. We obtain 2x. We can write it as minus 3 over 3x plus 2 power 2 plus 2x. Now let's consider the domain. When x is less than minus 1, so when we replace x by a value which is less than minus 1, the denominator will always be positive because of the square here. But when we take a negative value, that is minus 3, and we divide by a positive value, the final answer will be negative. Similarly here, when we take 2 and we multiply it by a negative number, we obtain a negative answer. And then we have to add two negative values. So the final answer again will be negative. So f dash of x is negative or less than 0 for the given domain, that is for x is less than minus 1. Therefore, we can conclude that f is a decreasing function. So when the gradient is negative, we have a decreasing function. Question number 2 now. the graph of y is equal to fx is transformed to the graph of y is equal to 1 plus f of half x. Describe fully the two single transformations which have been combined to give the resulting transformation. So this is a newly added chapter, which is transformation of curve. So there are two single transformations here. Let's see the first one. We have f of half x. So y is equal to f of half x is a stretch of y is equal to fx parallel to the x-axis by a scale factor 2. So this is the first transformation. When we have half x, the scale factor is 2. Now for y is equal to 1 plus f of half x, this one is a translation of y is equal to f of half x by 1 unit along the y-axis in the positive direction. That is, we translate the curve by 1 unit upwards. Or we can write it as translate f of half x by the vector 0, 1. Question number 3. The diagram shows part of the curve with equation y is equal to x squared plus 1. The shaded region enclosed by the curve, the y-axis and the line y is equal to 5 is rotated through 360 degrees about the y-axis. Find the volume obtained. So this is the enclosed region bounded by the curve, by the y-axis, by the line. Y is equal to 5 and y is equal to 1. So when this region is rotated 360 degrees about the y-axis, so we rotate this region, we obtain a 3D object. So this 3D object is called a solid of revolution. And now we have volume. So it is volume about the y-axis, and the formula is V is equal to pi integral of x squared dy. This is a formula for volume about the y-axis. So we have V is equal to pi. The limits are 1 and 5. And now we have to find an expression for x squared in terms of y. So the equation of the curve is y is equal to x squared plus 1. So x squared is equal to y minus 1. Here we have y minus 1, and we integrate with respect to y. So volume is equal to pi. We have y squared over 2 minus y. And here we have the limits. Now we replace by 5. We obtain 25 over 2 minus 5 minus, next we replace y by 1, half minus 1. And the final answer is 8 pi unit cube. So this is the volume. You must not forget the pi. Question number 4. A curve has equation y is equal to x squared minus 2x minus 3. A point is moving along the curve in such a way that at P, the y-coordinate is increasing at 4 units per second and the x-coordinate is increasing at 6 units per second. Find the x-coordinate of P. So again, this is chapter differentiation. It is an application of differentiation called rates of change. So the equation of the curve is y is equal to x squared minus 2x minus 3. Next we have at P, the y-coordinate is increasing at 4 units per second. So this is a rate of increase of y. This can be written as dy by dt is equal to 4 units per second. And at P, the x-coordinate is increasing at 6 units per second. So we have the rate of increase of x at P. So at P we know dy by dt, and we also know the value for dx by dt, the rate of increase of x. This is dx by dt, which is 6 units per second. So we have to find the x-coordinate of P. So from y, we can obtain an expression for dy by dx. This is 2x minus 2. And dy by dx can be obtained by dy by dt times dt by dx. This is called chain rule. So dy by dx, it is 2x minus 2. dy by dt is 4. dt by dx, this can be obtained from dx by dt. So if dx by dt is 6 units per second, dt by dx, we take the reciprocal, which is 1 over 6. So here we have 1 over 6. 2x minus 2 is equal to 4 over 6, which is 2/3. And then we solve for x. We obtain, this is 8 over 3, and x is 4 over 3. So this is the x-coordinate of P. Question number 5. Solve the equation tan theta plus 3 sin theta plus 2 over tan theta minus 3 sin theta plus 1 is equal to 2 for theta lying between 0 degrees and 90 degrees. So this is chapter trigonometry. And for trigonometry paper 1, any question can be solved using only these two. Tan theta is equal to sin theta over cos theta, and sine square theta plus cos square theta is equal to 1. So these two are enough to tackle any question for trigonometry paper 1. You don't need to use compound angle or double angle formula. These will be used in trigonometry paper 3. So now for this expression we can cross multiply. When we cross multiply, we obtain tan theta plus 3 sine theta plus 2 is equal to 2 tan theta minus 6 sine theta plus 2. Then we simplify it to obtain tan theta minus 9 sine theta is equal to 0. So as I told you earlier, tan theta can be written as sine theta over cos theta. Next, we take sine theta as common. We have 1 over cos theta minus 9 is equal to 0. So sine theta is equal to 0, or 1 over cos theta minus 9 is equal to 0. 1 over cos theta is equal to 9. Cos theta is equal to 1 over 9. So here sine theta is equal to 0. For theta lying between 0 and 90 degrees, we consider answer only in the first quadrant. So theta is equal to 0 degrees. Sine inverse of 0 is 0 degrees. And here also theta is equal to cos inverse of 1 over 9. Again, we take answer from the first quadrant only. So the answer is 83.6 degrees. We have two answers, 0 and 83.6 degrees. Question number 6. The coefficient of 1 over x in the expansion of 2x plus a over x squared the whole to the power of 5 is 720. Find the possible values of the constant a. So here we can expand the expression 2x plus a over x squared power 5. So we have 2x power 5 plus 5c1, 2x power 4, a over x squared power 1 plus 5c2, 2x power 3, a over x squared power 2 plus 5c3, 2x power 2, a over x squared power 3 plus 5c4, 2x power 1, a over x squared power 4 plus 5c5, 2x power 0, a over x squared power 5. So here we are interested to know the coefficient of 1 over x. We are not going to simplify every term, only the term which will give us coefficient of 1 over x. So here we have x power 5, here power 4 over power 2. This will give us x squared. Here we have x cubed over x power 4. So we will have coefficient of 1 over x. So we take only this part. So coefficient of 1 over x is 5c2, 2 power 3 a square. So we take only the coefficient, which is 5c2 10 times 2 power 3, which is 8, times a square. So we have 80a squared. This is the coefficient of 1 over x. And we equate it with 720. A squared is equal to 9. So we have a is equal to plus or minus 3. We have two answers for a. So you can use any other method, but we must arrive at this point, that is the coefficient of 1 over x. This is the most important part. 5c2, 2x power 3 into a over x squared power 2. And then equate it with 720, solve to obtain the values of a. Hence, find the coefficient of 1 over x power 7 in the expansion. So 1 over x power 7, that is x power minus 7. So we look for the term which will give us coefficient of x power minus 7. So here we have 2 over 5. This is coefficient of x power minus 3. Here we have 1. And then in the denominator we have 8. So x over x power 8, this term will give us coefficient of x power minus 7. So coefficient of x power minus 7 is 5c4 times 2 times a power 4. So we have 5c4, which is 5 times 2, and then a power 4, that is 10 a power 4. When a is equal to 3, we have coefficient of x power minus 7, 10 times 3 power 4, which is 810. When a is equal to minus 3, the coefficient of x power minus 7, again it will be 810. This is the same. So we have the coefficient of 1 over x power 7 as 810. So for the time being, I'm going to stop here. I will continue with the paper in my next video. Thank you.